I'm going to talk to you today about, I'm going to actually give you two talks in one. I'm going to give you both a talk on implementing Git in Haskell, but also I'm going to give you a talk on being a beginner with Haskell, because this is my first ever Haskell project that I wrote from scratch. Yeah, I hope that despite my relative inexperience, you'll learn something new today. And also, I've had absolutely no success explaining either Git or Haskell to people by talking at them. So feel free at any stage to stop me and ask any questions that you may have. I think it will be much, much better that way. So let me start with the what. So what is my library? So I've created a library. It's on GitHub. It's an API for Git repositories. So it provides primitives for you to inspect the things that make up a Git repository. And you can read them and you can write them. So essentially, you can manipulate Git repositories from within Haskell with Haskell code. It's pure Haskell, there's no shelling involved. The only time that I use Git is to test my code, because I want to test that Git's view of the world is the same as my view of the world. I think it's fair enough. So I was going to show you an awesome demo, but my laptop refused to cooperate with the projector, and instead I have GitHub. So I use Haskell notebooks a lot. I think they're really great. Can everyone read this? Is this too small? Do you need me to make it bigger? Bigger. Bigger? Okay, great. Let me see if I can do that. Yep, thanks. Yeah, I'm not very good at Macs either. Yeah, there we go. Is that, yeah? Bigger. Even bigger? Sorry? My text is, oh, that is so strange. It shouldn't do that. Let me see if I can. Make the what, sorry? Okay, just Control A or Command A. Nah, no help at all. Wait, so did it work when I?
You got it? Yeah, there you go.
It just becomes worse and worse. That is so bizarre. Whoop.
Leave it at one bigger than that, and then just go with it. Bigger.
What happens if I reload? Does it work better then?
Won't help. Just make it up to about 130% and just go.
130%, like that? Or is it even bigger?
Bigger. There we go.
There we go?
Perfect.
Okay, great. So you can, oh, okay, so you can see most of the text. I guess that's, all right, I'll take what I can get. So yeah, Haskell notebooks. I love Haskell notebooks. I think they're amazing. I think they're the way of developing in Haskell, because I come from a dynamically typed programming language background, and I really liked having the fast feedback loop that something like this enables, where you type some code, see it work or not work, and then you fix it. And GHCI doesn't quite do that for me, but this does. So just pretend that I've imported some stuff. That's what I've done. So you can get the most recent commit in a Git repository. Like a representation of what's actually inside the commit object. I'm going to talk about objects by using this git command. Can everyone see that? Yeah, you can actually. That's good. Yeah, so this is the most recent commit. So I'm currently on my master branch, and another way of getting to this object is by using my library. So my library basically, you can see the flip run reader t stuff. That's basically me saying that the Git repository lives at .git. So I resolve the refs heads master ref, and I get the same commit that I got before. As you can see, a commit contains a tree, a parent, an author, a committer, and a message. This output over here comes from the git command, and it's not actually stored inside the commit object itself. So as you can see, this output is more or less the same, and that's because I defined show instances on my types to make it look kind of like git output. A commit refers to a tree. A tree means a directory, it represents a directory. This is kind of like what oh no, what have I done? Oh well, no, not that either. So this is what a tree looks like. So a tree can refer to either a file, in which in Git lingo is a blob, or another tree, which again refers to a blob. And yeah, so there's there's a Git. So Git has this porcelain plumbing distinction. So porcelain are the commands that you interact with as a user. Things like add, commit, push. Plumbing are commands that are used under the hood to implement those commands. And I think this is pretty much exactly like a toilet. So you have your porcelain, you have your plumbing. No, this is the terminology that Git uses. These are technical terms. And there's a plumbing command called catfile, which will unzip, and I'll get into the zipping stuff later, and pretty print a Git object. So this is what a tree looks like. This is the contents of a tree. So a tree is more or less this text file that has been compressed. But I'll get into that a bit later. So this is how you do it with Git, and this is how you do it with my library. So pretty much the same output, except for like minor formatting. So the way Git works is that it implements a giant hash table in the file system. And what it does is it takes some content, in that case, either like a file or like a directory listing or a commit, and it hashes it using the SHA-1 hashing algorithm, and then it takes the first 2 characters of that hash. It creates a directory under, anyway, I don't want to like, feel like I should either read or say and not have both of these things. But anyway, so yeah, it takes the SHA-1 hash, it takes the first 2 characters of the hash, creates a directory. The next 38 characters are the file name of the content. It's, so for example, .git/object/ blah, 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 blah. If I put it into zlibflate, which decompresses some content, I get that. So one thing I forgot to mention is that there's a null byte here, because Git has a header on each object saying what type of object it is and how long the length of the object is. Again, please feel free to stop me. I've tried to do this before, and people are like, nodding their heads, and at the end they're like, I didn't get any of that. Like, none of this made sense to me at all. This is just a demo. If it's okay, one, it's okay if you don't understand fully what's going on. Like I said, I've had no success doing this before. And 2, I hope that if I finish the demo, go through the rest of my presentation, things will make a bit more sense. If not, please either ask me now or ask me later. So this content and this content are more or less, the same content. You can do a Git branch, and you can I don't know if anyone's tried to do the caret or the tilde. So they mean 2 different things in Git. So the caret means the parent. So you can have multiple parents of a commit if it's a merge commit. And the tilde means the ancestor. So it has always the first parent or the first parent of that or the first parent of that. So somebody gave me very good advice earlier today about exactly this scenario where my laptop refuses to cooperate with the projector for whatever reason, or stuff, I don't know, catches fire. So which is why I have this completed IPython notebook on GitHub. So when you read an object and you hash it, you should get the same hash that you started with, and that's a pretty simple check. So yes, so in Git lingo, a blob is a file. So you can read that. For example, this is my license that my stuff is under. And there's a 4th type of Git object, which is a tag. A tag is an object that names another Git object. So you can tag a commit, a tree, a blob, or even another tag, although I have no idea why you might want to do that. So as you can see, I've demonstrated that my library successfully reads things. And but it can also write things. You can write a blob, and it can and Git knows that the blob is there now that I've written it. I actually in my demo forgot to remove this. So what I do is that I this branch is not supposed to exist, and then I create it using my library. But as you can see, it works, and I can so I can take this tree and add a new file to it with this code. And I won't get into the details of that because I can't really remember how it works, but it does. That's pretty much my demo. I realized I forgot to mention why I called it Duffer. So I called it Duffer because a 4th grade teacher of mine, my Hindi teacher, she called me a Duffer in class, and I felt really, really bad. I don't think I ever fully recovered. So many years later, when I was thinking of a name for my library, I thought, what is stupider than a Git? Anyway, I'll tell you a little bit of the code. So Git objects can be pretty compactly represented as a Haskell data type. Pretty straightforward. A blob is some content. A tree has some entries. A commit is a tree, parent, author, committed time, message. A tag is again, I've shown you this before. The types are, so this is I've just added this for completeness. This is just so you can see that this is pretty much literally everything in here is yeah, is the representation of a Git object. Like I said, this is my first Haskell project, so for me it was very interesting kind of like learning all this stuff. Not just like monads, you know, the scary M word, but also the stuff that builds up to a monad. And one thing that was really, really helpful to me was using the autoparsec library. And I think the autoparsec library is incredible. It's mind-blowing. It's like space-age technology. I love it. I think everyone, if they need a parsing, if they like have a parsing task to complete, should think, can I use autoparsec for this? Because it's that good. And it has like, obviously, it has a beautiful interface. I guess one thing that I like about autoparsec that makes it better, I think objectively better than parsec, for example, is that parsec has try backtracking. I'm sure most of you like kind of know that. If you want to backtrack, you have to go try this parse. If not, try this other parse instead. But autoparsec just has backtracking. It just works. And that's amazing. So anyway, this is I guess, you know, functor. And autoparsec, so it's one thing to like know what a monad is. It's another thing to know what the functor applicative monad hierarchy is. And it's another thing altogether to know why they're useful. And that third thing, I think, like, is kind of what I got from using autoparsec. So anyway, functors, a tree is so if I parse many tree entries, I get a list. If I want to go from a list to a set, I use from list, so on and so forth. Applicative as well, like autoparsec defines really nice ways of going, okay, parse the end of a line, don't really care about the end of the line, throw it away, give me what's after the end of a line. So that's what a message, that's what a commit message or a tag annotation looks like. Yeah, so this is another thing. So I've talked about my library once before, and the first time I did it, I felt really silly because I was threading my the path to my Git repository through all of my functions. Can you imagine all of my functions taking an extra parameter that goes? And then I was like, you know, there must be a better way. And I was, you know, like a few weeks later, I was reading this random blog post, and it went, oh, you know, you could use a reader monad for that. And I was like, oh, okay, so how do I use a reader monad, and how do I compose it with my I/O stuff where everything's happening? So monad transformers. So that's the way that I learned about monad transformers. Also convincing me monad transformers is a good idea. This is like pretty simple code, pretty obviously works. I like that. There's also streaming. So I like recently, so Git has this weird, so Git has two representations. It has this loose object representation that I was telling you about just now. It also has a pack file representation where it like smushes a whole bunch of objects together and uses that for compression. And because in the loose object representation, Git stores all versions, every version of every file, there's no deltas. But in the pack representation, it stores some objects as deltas against other objects. So it uses that for compression and for network transfer. So when you do a Git clone, your Git, the Git binary is literally downloading a giant pack file over a network. Like, it could be a giant pack file, it's usually pretty small. So the problem with the pack file though is that it interleaves compressed and decompressed content. I don't know if anyone ever noticed our Haskell thread that like a couple of weeks ago. It interleaves compressed and decompressed content, but it doesn't tell you how long the compressed content is. So you can't use zlib to eat the, because zlib will happily parse some content and then it'll eat the rest of it. It'll just throw it away. So anyway, you need a streaming decompression library. And this is really ugly. I'm not especially, I don't especially think that this is really good code. But I asked a friend of mine who's a much better Haskeller than I am, and he kind of went away and a few days later was like, you know what, I don't actually think that there's a much better way currently. And that kind of sucks. I think there should be a better way than this way. So this is how my layout, should probably just mention how how everything's laid out. So it's laid out, so I have my loose object stuff and I have my packed object stuff and I have a little porcelain to make things a bit easier for myself. I'll get into why I had porcelain in there a bit later. And yeah, this is probably the most interesting part of the talk, maybe. If you already know Haskell, which all of you do. So I was working with a Git library, and I had a Git repo that was the library. So I was like, why don't I use the library, the repo of the library, to test itself? So what my tests do currently is that they actually grab the pack file, because whenever you push or pull, there's a pack file involved. So it takes a pack file, it uses my pack file decompression logic that I mentioned in the streaming section to pull it apart into individual objects. And then it uses the individual objects to test that its view of the world is the same as Git's view of the world. So you have, so Git has blobs, trees, commits, and tags. So my tests basically go, use Git to find out which objects are blobs, verify that those work correctly, use Git to verify which objects are commits, same, tags, same, and trees, same. So there's a couple of advantages to this approach. One is that if there is a bug in my logic, eventually I will find it. Like I have random, like essentially random test cases generated for me without having to learn quick check, which I do use quick check for. Sorry. Never mind. Yeah, without like almost like not random test cases. Sorry, that's the wrong phrase to use. I have test cases generated for me every time I create a new commit. So every time I create a new commit, I'm adding to my corpus of test data, which is amazing. I think that's awesome. I think that was a really good idea. I'm like, very self-congratulatory about that. So anyway, next I'll tell you about some of the concepts of Git that I encountered that I thought were pretty functional. One is the way Git stores tree data. So the tree contains the hashes of everything that, the tree contains not just the names of all the things that it refers to, but their hashes. So when the hashes of something change, then the tree object content changes, and when the tree object content changes, its hash changes. So if you imagine a giant graph of stuff, and something changes at the bottom, everything all the way up to the top will change, the hash of everything will change. So that allows you to accomplish the dual goals of storing the same content only once, but also storing everything. So every version of every file, every version of every directory listing is safe and sound in a Git repository. And when I say Merkle-DAG, I think that's a blockchain concept, possibly, but Git also in a commit has the hashes of its parent commits inside it. So every time you want to rebase or you do a cherry pick or whatever, you're changing those hashes. So you're actually creating a completely different tree, which leaves your original content completely untouched. And I guess that's one of the most important things that you can take away from learning more about Git is that Git stores a lot of stuff. It stores everything. It doesn't usually throw anything away, which means that if you make, if you do something and everything goes horribly wrong, as long as you haven't actually gone ahead and messed with your .git directory, you should be able to get back to the way you were before. And I think that's pretty cool. That's that's a very good safety guarantee. Yeah, so Git is designed as an append-only object store. It's garbage collected occasionally, every 30 days or something like that. But for all intents and purposes, it could be an append-only object store. But what it does is that it actually changes what the master branch points to, what a new branch points to, and that's the mutable ref store. And that's I think that's pretty functional. I'd say so anyway. So what is next for my library? So you can read and write Git objects, but there's other things that I think would be pretty cool. I'd like to use Servant or some other library to make a web application that would serve a Git repository. I think that would be fun. I'd like to have a better API. So currently, I can store an object. I can read a tree object, but that just gives me a list of tree entries. It should give me a whole directory. But that leads to problems with nested records, and I feel if I learn more about Lens, I could probably fix that. And I'd also really like multiple backends. I think that would be really cool because there's no reason that the backing store of a Git repository has to be the file system. It can be anything that can store it can store SHA-1 hash and a byte string. Anything that can do that is a potential backend for a Git repository. Yeah, so I also think there's some cool apps that you might be able to build. Maybe not with the library as it is currently, but yeah, but and theoretically yes. So why don't we have a project management system, for example, that can that always maintains its data, that always maintains all previous states, and using Git as the backend of some other application. So there's so let me give you some context. I used to be a web developer, and database migrations were the absolute bane of my existence. Not because they were tedious and boring, but because I was always worried that somehow migrating data, I'd lose something, lose some customer data. And they'd be unhappy, I'd be unhappy, everyone would just be unhappy. And I think that's because, as far as I'm aware, a database goes, look, we'll handle your schema migrations for you, but the data, you're on your own. Whereas Git is the opposite, or something like Git. It says, look, make sure that every version of your data is kept safe. But in terms of schema migrations, you're on your own. However, I think it's much easier to build something that keeps schema migrations safe, keeps every schema migration safe, than it is to build on top of immutable, an immutable object store, than it is to build immutable data on top of mutable object store. So I think there is potential here to do something really cool with Git or something like Git. But yeah, interested in like hearing what you guys have to say about that. Or yeah, either like now or later or whenever. So I guess I feel like the most inexperienced Haskell programmer here. Does anyone else feel kind of inexperienced? A little bit? Okay, good. Don't feel alone. So this slide is useful. I wanted to give advice to like past me, which I hope might be helpful to anyone else. Yeah, so one thing that I would like have liked to tell myself is not to get too hung up on like completely understanding what a monad is before writing any code. Because when I first encountered Haskell, when I first decided that okay, I'm going to like dive deep into this thing, I was like, okay, I need to understand monads. That's the first thing I need to do. Everything else can kind of take a backseat. And I feel like that's a wrong approach to the problem. What worked for me, instead of trying to understand monads, was really try to understand do notation. Because if I understood do notation, then I could use that to do things with monads. And once I understood how to desugar do notation, like all the concepts of, concepts about functor, applicative, and monads started making a lot more sense. I also like made the mistake of asking questions on on Stack Overflow a lot. Like, that was my place to go to. And like looking back, that was a mistake. I think it would have been much easier, much better to get support on IRC and Haskell. And IRC and Haskell are amazing. Like people like Gabriel Gonzalez, like Edward Komet, just so many people like Mighty Butt. All of them are like on IRC and Haskell. And I think that would have been a better place to look before. And I definitely didn't feel supported by Stack Overflow at all. I felt like, going into like, I don't even know how to describe it, like just putting something out there and the hope, naive hope that maybe someone would help me. But IRC and Haskell, like Haskell beginners, for example, are amazing. And also, one decision that I made that has like paid off tremendously was learning about Haskell and using Haskell. I think it's a godsend, like seriously. Like imagine writing opening up a text editor, like most of us do, typing some code in, watching like our type checker stuff tell us that our types are wrong, trying to fix that, going over and over and over again. Okay, finally, like it kind of compiles, it kind of works. Oh wait, no, there's I made a logic error somewhere. Going back and fixing that. It's frustrating, but Haskell allows you to do that same thing and get a much quicker feedback loop. And I think the feedback loop is really, really amazing. It's really like, I think it like, I don't know how to explain it. It motivates me to keep going instead of going, okay, you know what, just leave this aside and go do something else. So it's not all, it's not all roses. Some things about Haskell I'm really not a fan of. I find the documentation for a lot of the libraries that I use pretty awful. Like, I find that a lot of the insights that I've had, a lot of the the ways to use things have been from random blog posts. And random blog posts are cool, don't get me wrong, but they're definitely not what we should be using as our, as like the standard way of learning stuff. It's hard to find the right libraries as well. I don't really know what the solution to this is, but again, random blog posts, like there has to be a better way. And then the learning curve, like I would agree that the learning curve is pretty demanding. It sounds a bit self-congratulatory of me to like talk at Haskell users group about a project and say that learning curve is very demanding, but I definitely see that a lot when I try to like, I think if more people wrote Haskell, the world would be a better place. I think if a lot more things were written in Haskell, the world would be a better place. And I feel like the way to do that is to like teach people Haskell or like get people excited about learning Haskell, and that's hard if the learning curve is so demanding. So my background with Haskell is a bit like interesting. So I say this is my first Haskell project that I wrote from scratch. I was exposed to Haskell for the first time at my university. So I went to the Australian National University, and they still use Haskell in their introductory programming course. And I was exposed to first-class functions before that with like Python, and I knew enough to kind of go through the class. I did okay. And then I didn't really see what the point was. I was like, it's cursive, it's immutable instead of my loops and my iteration. I don't really see what the point is. And then I got my first job. I even tutored the Haskell course, in fact. I tutored the Haskell course as I was getting like my first job, and I wrote my first giant bug that my non-testing self couldn't find, couldn't fix. And I had no idea what to do. And then I looked back and I was like, you know what? This is the kind of thing that probably wouldn't happen with Haskell. And then I got got another job, and this company that I worked for, they use Scala. So that was another thing that kind of changed my perspective, because I don't think I'd ever seen anyone use functional programming in industry before. And the fact that they use Scala, I was like, okay. But then I tried Scala, right? And I didn't enjoy it. I didn't enjoy it at all. I can get into that later if anyone's interested. But yeah, no, don't. I wouldn't recommend it to anyone. So I don't really know what the answer is. Like, how else do we provide a compelling reason to learn it? I think, like, currently my opinion is that we, like, or at least I need to, like, seed the idea that, like, Haskell is a good idea. I just need to tell people that Haskell is a good idea. I don't need to tell them that they should drop everything and learn Haskell now. I don't need to tell them that, like, it's a solution to all their problems, even though it might be. I just need to tell them that it's a good idea. This is why I got into Haskell. And then maybe later, when in their own time, in their own space, they think about, they encounter a solution where, like, a problem where Haskell might be a solution. They'll come back and maybe I can help them with that at another time. So yeah, so this library, what can you do with it? I wanted to run a Git internals workshop, and just because of all the stuff that I've learned while writing this library. And I thought, how cool would it be if my Git internals workshop were itself a repo, and I'd open up the repo and step through different tags in order to, like, go through the stages of my thing. And I was like, oh, I don't want to do all the cherry picking and rebasing and copying files around. That sounds awful. But then I remembered, hey, I've been working for the last 6 months on this library that literally creates repos for me. Maybe I should use that instead. So I did that. It works. I was pretty surprised. It's the first time I actually tried to use the library that I wrote for anything. It exists. It's on GitHub. I can go through it if you're interested and if we have time. But otherwise, I will point you at other stuff. So should you use this library in production? No, don't use it. I don't want to support you, like, using my library. I can't see that being a good use of anyone's time. But there are other libraries that are better. For example, that first one is used by Stack, amongst others. It's pretty great. I highly recommend it. It was useful for, like, fixing some of my, my, like, logic errors or bugs, or trying to figure out how things would be implemented. It kind of also gave me the confidence that I could implement it in Haskell, just because I knew that at the end of the day, if I really couldn't figure out how to do something, I would be able to look at the source of this library and the answer would be there. There's also this thing that's like, Git interface with many backends. And there's someone who I think now works at Atlassian, I'm not completely sure, who actually went and implemented enough Git to do a Git clone. I haven't quite gone that far, but this is another thing this was actually, like, really useful. He has pictures and, like, goes really in depth on some stuff. It was very, very cool. So I've been talking to you about, like, multiple backends. I've been talking about how great Git would be as a backend for something. There's already something like this. The only problem is it's for OCaml and not Haskell. And this upsets me. This makes me really sad. I really want something exactly like this, but for Haskell. And yeah, it's called Ermin. It's pretty great. It's definitely a lot better than my library. And if you use OCaml, you're golden. You don't need to worry about anything. You just use that instead. So so at the end of the day, so my presentation, as you can see, is on my website or my GitHub pages. I can, like, if anyone's interested, I can talk about how I get all of that work together. But it basically involves using CI, twisting CI to my own nefarious purposes. The code is on GitHub as well. And in lieu of, like, the employer slide that I might put up, thought I'd tell you about RC, where I've been for the last 6 weeks. And I'm basically working full-time, like, more than full-time, on this library. And it's been really, really amazing. And I like it a lot. And I encourage you to check it out if you're interested, or talk to me or any of the other RCers here about it. And that's all I have for you. Does anyone have any questions? Yes. Yes. I haven't met him, no, but I have a friend who actually works at NICTA. Well, the organization formerly known as NICTA, and he was telling me once after I started doing the Tony Morris course that I was in Sydney last weekend, just, like, hanging out with Tony Morris teaching, like, the Tony Morris course. No, I haven't met him. That's unfortunate because I lived in Canberra for 6 years, and
I'm just curious. He's a very interesting person.
I would absolutely love to meet him, but. Yes.
How easy is it to start using iHaskell? Is it difficult to set up, or is it just, like, a couple of keystrokes?
It depends on which method you use to set it up. So I used to, like, so my first love is in terms of programming languages was Python. So I take very good care of my Python environment. which made like setting up IPython and iHaskell a bit more complex than it could have been. Otherwise, I think there's instructions on the website. There's a script that will install it for you. You can usually go stack install iHaskell, and that'll install the iHaskell kernel. But if you've already installed the Jupyter notebook, everything should, like, it's pretty straightforward. I think I've had kind of issues with setting up in the past, but at the moment, I think the biggest issue is that it doesn't support GHC8, and this is the only thing that's keeping me on GHC 7.10. Like, if iHaskell switched, like, finally started supporting GHC8, I would switch tomorrow. I've actually, like, I don't know if I don't know if it's worth pulling it up, but I actually, like, put an issue up about this on the iHaskell thing, and Andrew, like, he said that he was working on it and it will be out in a few months. So I'm pretty excited for that. Any other questions? Yes. Oh wait, no.
You mentioned if you had time, you would go to the Git workshop.
Yeah, I could. I'm not using my own laptop at the moment, which makes things a bit harder. I don't really understand how to, if it's okay for me to.
Presentation on IPython notebook you want to get.
Sorry?
You have a presentation on IPython notebook?
Oh, in my repo, you mean?
Yeah.
Oh, I see that you're way ahead of me. No, that's not. So that's kind of, so like I said, I use IPython, iHaskell pretty much exclusively for development. So when I was trying to figure out how I'd use my library to build the repo in the first place, that was an IPython notebook, and I thought, why not commit it? But then I actually went ahead and just changed that to, so yeah, so I'm just I guess for completeness, let me show you the thing. This is just like, how would you use my stuff? This is junk. You know, and like, this is writing things out one by one. I'm like, this is awful. Why am I doing this? So what I did instead is I wrote some code that was simpler. So I have like, so this creates a step. I updated my library with some porcelain to make some things a bit easier. So I can like write a tree, I think. There's a like write tree in here somewhere, I can't see it. Sorry, line 38? Oh yeah, here we go. Great, thank you so much. Yeah. So write tree, what it does is that it'll take a directory and create Git objects for each directory listing and each blob, so recursively. And so things like that, things like that are doable in code much easier. So this is like, it's a 5-step workshop. I'm not really sure how all the logistics are of me like doing a Git clone. Maybe this is a better talk. Maybe this is a better topic for a lightning talk. Hey, I don't know. Would anyone like to see that? Yes, no? I'm gonna say no. Okay, there was a question from the person next to you. Yes.
So I'm just curious, what was your inspiration behind this project or any of the
Okay. That's a good question. So what happened was in Canberra, where I used to live, a friend of mine from university, when we tutored the Haskell course together, started a functional programming group. And I started attending because I wanted to, like, I was really interested in functional programming. I was like, kept trying, I'd made several abortive attempts to actually learn how to use Haskell. And they were really helpful because they actually, it's David Pedersen and Alex Mason, if you're interested. And I think David Pedersen actually had, he had this thing called Feely, Fuzzy, Touchy, or something like that, that basically renamed the whole functor applicative monad thing to something that was a bit more palatable, a bit less scary. That was pretty cool. So anyway, so I really wanted to like be part of this group, right? And I was like, okay, I'm relatively competent Git user. Can I give my using Git talk? Because Git is functional, right? And he's like, you know what? No one's really interested in that. Like, we all know how to use Git. What would be cool though is if you learn how to implement Git and gave a talk on that. And and here we are. Yeah. Nobody has any questions? Did everyone like actually understand my demo? I feel like that's that's very, very surprising. I've done this like before and it just failed miserably. So I was half expecting you guys to be like spending most time kind of like stopping me and be like, whoa, I didn't understand that. Like, can we go back to that? Is there anything here that like you guys wanted to ask about? I mean, oh yes, question. No, my library does not handle the Git index. That's a very good question. Thank you so much. I actually have like the beginnings of, I don't know if it's in here. I think it is. I have the beginnings of an index parser. and an unparser. But the thing is, there's 3 different index formats, and I only figured out how to handle one of them. And I thought instead of like saying that my library can handle this now, it should handle all 3 index formats. So, but anyway, yeah. So this is like the thing is, the index entry is stat data, is like the stat Cisco data just put in a file, and it's pretty awful. Like, look at it. You know, this works. This does the thing correctly, but it's awful. And I'm not. You know, I definitely want to either figure out how to express that better, or at least extend it to work with the 2 other index formats. So this is index format 2, I believe. There's 3 and 4. I don't think 1 is used by anyone. But anyway, that's the thing, right? So Git is, then another reason Git was such a good problem domain was that the core of Git is very simple and straightforward. You know, I do this party trick now. I call it a party trick, where I can take 15 minutes, walk someone through the content, like what makes up a Git repository of any one of their projects. And that's pretty straightforward. But actually, like implementing everything, including the pack file logic, the index reading, like the weird porcelain stuff, is fiddly, and that's been really good learning as well. Yes?
Why are there 3 index formats?
Presumably, so there's 2 pack file formats as well. So I think the answer to the latter question is the same as the answer to the former, which is that they started with 1. They're like, no, this doesn't handle some things really well. I think the index format number 4, it's like a split index. So like some content is in one index and some content is another. It's bizarre. Like, you know, legacy code, right? I don't know. Oh, okay. Interesting. Yeah, so the index is the answer to the question of if Git represents all of this stuff, how does it know so quickly when I do a git status what's changed? So what Git does is it creates an index, which is a list of all of the blobs and their last known file modification time and some other metadata. So every time you change a file, it compares the entry in the index against the stat data of that file and goes, oh, something's changed. Sorry, was there another question that I cut off?
Well, the other thing in an index is it basically has like the intermediate states of trees that have not been committed yet, because it makes a block as soon as you like it as a file.
Yep.
But it doesn't create trees until you find the commit.
Thanks, I actually did not know that. Anything else? I was really worried this talk was going to be too short, so I was like, it's okay, I'll make it up in questions. But I think that strategy has also failed.
That's fine. If you want to show us the demo that we talked about, the internals thing, you have time.
I have what, sorry?
You have time if you want to show us.
Thank you. I actually need to like open up like a terminal and like clone stuff, and I don't know if that's okay. Sana, is that okay?
Okay, maybe we'll practice speaker, take a break, and then you can come back and you have to prepare later.
Okay, sure. Thank you.